All right, so we're going to talk about full wave rectification.
Okay.
Now you know that you have your AC waveform here, right? And you know that looks like.
Yes. Oh, yeah.
Right? Okay. And so you've seen this. I'm drawing this from memory, so it might be wrong.
This one is just pointing down.
Pointing down.
Yeah, like that.
Right? Okay. And so. Right?
Yes, and then that. Yeah.
Right?
And I think this is negative and that's positive. I think. Yeah. But it goes down that way.
Right? And so you want to have this. So this is positive?
Yes.
So we want to have this go to an LED.
Yeah, that's the light bulb.
Right? We got to have a current limiting resistor. We talked about that before.
And then do we have the what's it called?
Capacitor?
Yeah, capacitor.
We'll talk about that in a second. All right. So this guy has two states, right?
Okay.
Positive and negative, right? So we'll model it. Let me get the other colors. All the colors. All right, so we're going to model that as on, off, on, right? So we'll just model it. Just pretend. Don't worry about the curves. We'll just say it's all the way on positive, all the way on negative, all the way on positive. All the way on negative.
Okay.
Right? We'll just do that.
And when it's on negative, the light doesn't. It's not on.
It definitely is. So let me show you how it goes.
I thought that it blinked. So when is it blinking?
So if you don't have a capacitor, the light's not on here.
So
There's not much current flowing here because the voltage is so low, right?
Okay.
But here and here it's definitely on. And let me show you how. All right, so you got two cases. We've simplified this. Instead of having all of these different voltages, we simplified it into two voltages, plus and minus. Right?
Yes.
So let's talk about the plus case. Right? Okay. So in the plus case, this is plus V, and this is minus V, right?
Yes.
So this would be, so this voltage right here is, let's say this is 5 volts, and this is negative 5 volts, right? So this voltage from here to here, if we put a voltmeter here, this would be 5 volts, right?
Yes.
I'll do this with a dotted line because this is a voltmeter. So this is a DML, the thing we use to measure voltage.
Okay.
Right? So this is telling you this is plus 5 volts, right? From here to here,
Okay.
right? You follow me?
Yes.
So if there's plus 5 volts, where does the current want to flow?
Positive. So up here.
Yeah, so it wants to go this way, right?
Yes.
Because it wants to go from positive to negative. So the current's going to flow, right? It's going to happily flow. It's going to get to here. Where does it want to go? Can it go this way? Can it go this way?
No.
Why?
Because the diode, it doesn't allow. It only allows it to go downwards.
Right. So it's only a one-way. It's a one-way valve, right?
Yes.
So, but can it go this way?
Yes.
Right. So it's going to want to go here, right? And it gets to here, and then where does it want to go?
Out.
Right. Can it go this way?
No.
No. So it can only go this way, right?
Yes.
Oh, I get it.
And then it gets here, and then where does it want to go?
You know what's happening?
Down.
Right, because this is higher than this, right?
Yes.
Because the voltage has been dropping every time it goes through stuff. So this voltage here is lower than this voltage here,
Okay.
right? But it can still go this way, right?
Might not.
So while it could go this way, because this voltage here is not very high, and this is the highest voltage of the system, it won't want to go that way. It could, it doesn't want to,
Okay.
right? So it's going to go, and it's going to go down here. Back to 0. You follow me?
Oh, I get it. So it's one whole thing.
So it's one. So
It's
that's
one
one
whole
thing.
thing.
Right.
Okay, yeah.
Because these two don't let anything flow
Backwards.
when it's in like this. All right.
Okay.
So let me see you. So all right. Case 2.
But how does that? What does that mean? What does that have to do with the not going negative?
Right. So that's the easy one, the positive one. I just did the easy one. I'm gonna have you do the negative one. Right?
Okay.
So I'm gonna start you off. I'm gonna set up the system,
Okay.
and then you're gonna do it with the green one.
Okay.
All right. So you got hash marks here, right? So that means that if this is negative, right, that means this point is higher than this point. Would you agree?
In voltage?
In voltage. So if this is negative 5 volts, if this all of a sudden is negative 5 volts,
So you're saying negative 5 volts is higher than positive?
so negative 5 volts is the same as taking a 5 volt system and flipping it backwards. So if this is at, let's say this is at negative 5 volts, and this is at 0 volts, right?
Okay.
So
Oh yeah, I see.
So, I'm sorry, I took one step ahead. So this is negative 5 volts, and this is 0 volts, right? Because we say this is from, this here is graphing the voltage difference between these two, right? So this is, if we look at this graph, this is always at 0, and this changes from +5 to -5, right? It's always changing,
Okay.
right? So this is -5, and this is 0, right?
Yes.
Wouldn't that look the same as if this was 0 volts and this was +5 volts? Because this is still, remember, voltage is all relative. So 0 volts and -5, this is 5 volts lower than this, right?
Yes.
0 volts and +5, this is 5 volts less than this still, right?
Yes.
So it's still happy, right? It's just you're playing with math.
Okay.
You know, it's tricky to think about.
Yeah, I see. Cause
So I'm going to erase this. So you agree that's the same.
yes.
So I'm going to erase this.
Okay.
So now, if you look at these two, so you've got 5 volts here, right? And this is put plus and minus, right? So this is the same 5 volts, but instead, this is minus and this is plus.
Okay.
You think
So
about that for a second?
it just like switched.
Right, because it switched
It's, yeah.
switched to
negative.
opposite. So what was 5 volts here is now -5 volts here,
Okay.
right? So it's backwards. So we've got 0 volts up here and +5 right here.
Okay.
So if we have 0 volts here and +5, where's the current want to flow? Where does it start and where does it want to flow?
Doesn't want to go from positive to negative?
Right, so positive, now it wants to go from positive to negative. Before it wanted to go from positive to negative, but now
It wants to go
this side is the positive side.
Okay.
So in the future,
So the loop would change.
So if this is positive and it wants to get to negative, your arrows are now going this way.
shrink around where
So this is when it was going up,
Right, that's the red one.
and then but it can't go this way or something.
So now this is, since this
so
is
we
the
don't
positive
worry
side,
about them touching?
this is positive and this is negative, because this is +5 volts, this is 0 volts, which is the same we agreed as this being -5 volts and this being 0 volts, right?
Yes.
We agreed that's the same,
Yes.
so we're just talking about it in a different way. So it's basically equivalent to taking a battery that was 5 volts and flipping it upside down,
Okay.
putting it in backwards.
Okay.
Like that's what you're doing here when you make it negative.
Okay, but it can't go negative. Let's just say.
Well, it can. So the current wants to go from here through something, and it wants to come back here. Right?
It can't.
Well, can't it? So it wants to do that, right?
Yes, but
So let's see what happens.
doesn't it only stay above the line?
What's that?
Doesn't BC stay above the line only?
It does. So that's over here we're talking about, right?
Yes.
So this is the input. We'll talk about this, how it turns into DC in a second.
What?
So I want you to show me where the current flows. So you see how I did all these arrows?
Yes, that was easy.
So I started this one, right?
Okay.
So if this is plus 5 and it starts here, start making the arrows just like I did.
So you have this,
Yeah?
then up here.
Yeah? And then where does it go?
It can only go this way.
Right, because this is positive, right?
Yes.
Okay. And then where does it go?
It can only go this way.
Right, because this is blocking it. Right? So what's happening?
It's going on the same route.
It's going on the, well, yeah, it's going to go through here the same way it did when it was positive. But let's finish this up. Finish up your arrows. Let's take it all the way back to ground. Yeah? Good. Then where does it go? Right?
And then back up here.
Right? And then where does it go?
Well, just around.
Well, no, so here, this isn't connected.
Oh, yeah.
You gotta get home.
Yeah.
Can it go that way? Because remember, this is positive 5 volts here.
Wait,
So
hold
this is higher than this.
on. Wait. I'm confused.
So you have plus 5 here,
Yes.
right? You agree? So that makes this point plus 5 here,
Okay.
right? So your current flows like this, right?
Yes.
And it gets to here. And so these all have dropped the voltage, right? So the voltage here was 5 volts, and then now it's at like, because there's voltage dropping across here, so now it's like 4.5 or something, and then drops across here, so now it's at like 3.5, and drops across here, so now it's like 1.5 or something like that. And then it gets to here, so you're at 1.5 volts, but this is 5 volts, and this is 1.5. So the electrons don't want to go through here.
But why is this 5 volts? Because
remember we said
the
it was
red
5.
just went.
But the red's not on. So
Oh.
we're not playing with the red right now. Because the red is only for this when it's positive,
Okay.
and the green is only for this when it's negative,
Okay.
right? So in this green case, ignore the red.
Okay.
So you shouldn't see any red here.
Okay, I was seeing you.
All right. So in this green case, you've got this at 5 volts, because we agreed this is 5 volts and this is 0 volts,
Yes.
right?
So it's gonna want to
if
keep
this
going
is
to
5,
0.
right, it wants to get back to 0. It doesn't want to go back to 5, it was already there.
So
I think I'm bad at work.
does it want to go out this way?
Yeah, because this is 0, right?
Yes.
Wow.
And then it's back home. So it made it back to 0.
Okay.
So this is the way current flows in the 2 different cases that we have.
Well, I mean, this part is
Yes.
Now, on here, you notice the current's always flowing the same direction
Yes.
in both red and green. So that means this is always positive and this is always negative,
Yes.
right? So you've got DC here,
Do it the right way,
Yes.
not the lazy way.
despite having AC here. You have only positive voltages here, but you've got negative voltages here. And the reason is because these diodes use this clever trick of directing the current in the 2 different cases that this guy is in to make it go and generate a DC voltage.
But wouldn't so it's still saying positive when it's going up here? Like this is like it's still.
So you're talking about the green path?
Yes.
So you're talking about the green path. And so the green path started positive,
Yes.
right? It went through this diode because that's the only way it can go.
Yes.
It went through this because that's the only way it can get back. It wants to get back to here. It goes to here. And then remember, it wants to get back to here. It doesn't want to go here. It wants to get back to here.
Okay. I don't understand the pluses. Like the
So
positive.
the reason I flipped this,
No, like how? What's the difference? Like why? What's the positive and the negative in this circuit? Like I understand like the reason that you flipped it.
right? So this would be, so the current flows from positive to negative.
Okay.
So this would be positive and negative. Positive and negative.
Oh, okay, I got you.
Because the current is always flowing that way.
Okay.
But like here, the current's flowing one way when it's red and the other way when it's green.
Yeah.
Because this has been flipping back and forth between positive and negative.
So why does this flip?
Because that's just what this voltage is doing.
And then it keeps, but on the thing it's only on the top.
You mean out here?
On the DC.
Yeah, so out here, it's only...
Oh yeah, you're right.
Right? That's what you get out there?
Yes, but in the whole thing, okay, yeah.
So let's think about that, because you know this takes a little bit to really understand. So you think you could draw the arrows again if I erased them all?
Yes.
All right, so let's try that. I'm gonna erase everything. I'll probably be less fun. So you have. I want to see you explain it to me.
Okay. I don't know how to explain it.
Sure you do. I'm gonna get an orange, and you're gonna explain it to me. Okay. Go ahead. You can start. Oh boy. Oh boy is right. You should be excited.
Okay, cut it. Because it was like, when it's on,
Maybe we'll have you do the lecture tomorrow.
when it's on.
I don't know about it.
You don't know. All right. We'll see how you do here, and then decide about the lecture.
So I just explain everything to you.
So how do you solve it?
So this is the AC.
How does it work? Yeah.
This is the 8 alternating current, and this is how it is on the voltage meter.
Right.
And this is the positive, and this is the negative and positive.
Right.
Okay.
And then that's the AC. Is that how you draw it, the AC?
It's a squiggly horizontal.
Oh yeah.
Anytime you want something to happen, you gotta switch for it.
Yeah, that's good.
And then it's, it comes out.
Yeah.
This is four.
Okay. So. Okay.
And then how do I draw the light? I was like that.
It's the same thing as a diode. It just has a little lightning bolt coming out of it.
Like where I put the light.
Good.
And then
Right. And then don't forget your. What are you going to add here? What else do you need whenever you use an LED? That's right. Current limiting resistor.
Okay.
yeah.
Need it, David.
Yeah, first time a lot of work. Yeah.
Am I gonna have to draw it in the video?
Yeah.
You could start with a drawing. And explain
It's
it.
kind of messy.
So why don't you explain it now? Let's see how it goes.
So this is the circuit, and this is the AC power source, and then this is the diode bridge. And basically what the diode bridge is, they keep electrons flowing in one direction, and it keeps the current on the DC, and it keeps it positive when it's running through the resistors.
So show me how the current flows into two different cases.
So for red, when it's +5.
Japanese.
I think it's the wire.
Japanese.
It looks fun. No, that's. I already said that.
French.
So which one is the battery's negative?
Japanese. Spanish.
Hang on, I can't see.
Spanish.
There you go.
Can you go like?
Good.
Spanish.
So that's the easy one, right?
Yes.
All right. So now explain to me what happens when it goes negative. Let's talk about the green
so
case.
when it goes, can I stand on this side because it's on my hand there. And so, but when the voltage goes negative, it goes like this.
Once you get started. Okay. There you go.
And these basically get switched. So it starts out on this side.
Right.
And it goes.
Right.
That's working. So, do you have the memory card in there? Okay, so you should be able to like turn it on. Hopefully you'll be able to see this.
And it stays positive through the resistors.
Right, because that current's flowing the same direction. That's good.
fresh.
I was wondering where it was for a second.
And there you go.
Dale, reset it.
Well done.